Let's complicate things. Let's add in that extra variable, the movie duration. So now we'll have one more continuously measured variable. You'd want to start with the summary of movie duration. It's continuous. You could present the mean and the standard deviation. You could look at the distribution of it. But I'm going to leave that for you to do in your time. Let's look at how we're going to integrate that into the relationships. Movie duration. Is that necessarily only a predictor or only an outcome? I don't think so. I think it kind of could depend. That we could look at, does the year predict the movie duration? But we could also look at, does movie duration predict the age of award? So we've got 4 variables: gender, age at award year, and movie duration. Now, gender, we've said, is only going to be a predictor. Nothing's going that's not going to be an outcome of any of these variables. Age at award, we've used as both a predictor and as an outcome. The award year, we're pretty much only using as a predictor. And movie duration, we're going to use that as both a predictor and an outcome. So let's take a minute and think about all of the combinations that we should consider. We could look at movie duration by gender. So that would be movie duration as the outcome, gender as the predictor, where we'd be asking, does the gender of the winning star predict the length of the movie? Is the distribution of the length of the winning movies different for the different genders? We could make the comparison movie duration by year of the award, where we'd be asking, has the length of winning movies changed over these years? And we could ask, we could make the comparison age at award by movie duration, where we'd be asking about whether the length of the movie relates to the age of the winning lead actor or actress. Those seem to be the sensible 2 variable comparisons, the one outcome, one predictor. Go ahead and take a minute and fill in the table and make sure that you're looking at which ones are continuous and which ones are categorical, and you're understanding how you would describe those relationships and how you would relate those variables, how you would evaluate those relationships. Let's start with the 2 continuous relationships. So that's movie duration and year of award, and the age at award and movie duration. Let's start by asking if the movie duration has changed over these years. So year of award is the predictor variable, movie duration is the outcome variable. To make it easy to upload and to see it, we just want those in 2 contiguous blocks. I can see I've got a column for year of award here. I'm just going to insert a column here. That's moved everything to the right. And then I'm going to come and copy column I and paste it just so I have those 2 next to each other. I've selected them both. I'm going to copy them both. I'm going to jump to see it, correlations, add a data set, paste. And this is duration by year. The first column is not a label. I'm going to uncheck that and load the data from the worksheet. So does year of award predict movie duration? We're going to put the year of the award along the x-axis, but let's start by putting the movie duration along the y-axis. I think you'll get a kick out of what that looks like. Do you see it? Do you see the distribution of the movie durations? So because we've only got one variable up there, it's just showing us a histogram. It's showing us a distribution. It's on its side, so you might have to, move your head so that you can see it properly. But you can see that that's a pretty nice normal distribution with a few outliers towards really long movies. So those are going up the scale. And now let's spread those out across the scatter plot by putting the year of the award along the x-axis. And so there they've gone. They've all been spread out across the year that they were filmed. Take a minute and try to draw the line of best fit. Try to encapsulate 95% of those and see what you predict as the strength and the nature of this relationship. And now let's have the program do it. So we have a correlation coefficient of 0.22. It's positive, therefore, what's the nature of the relationship? Positive, that's right. As one goes up, the other. As one goes up, the other also goes up. As one goes down, the other also goes down. 0.22, it's not a very strong relationship, but it is real. Why don't you practice what you know? Why don't you go back and do the same steps with the movie duration and the age at the award? See if movie duration predicts how old the winning stars were. Are you going to do it on your own, or are you going to watch me? Let's see, I've already got those two together, movie duration and age. So here we are with the scatter plot of, does the length of the movie predict the age of the winning star? With the line of best fit, it's a negative 0.06. That's really close to zero. In order to get 167 of these observations in, we pretty much need just a big circle. So that's showing that there's no relationship. That's a zero relationship. And that line is almost exactly at the overall average for age. We've thought about the combinations of two variables. I would like to dig a little bit deeper into this relationship. Well, we're seeing no relationship at the moment. I'm wondering if we've got two different groups mixed in, two different clouds of data spots. Maybe if we separate it by gender, maybe we are more willing to watch longer movies with younger actresses. Who knows? Let's look at the relationship between three variables. Does gender predict the movie duration and the age at award? Or does gender and movie duration predict the age at award? What I'm going to do is just separate those. So we've got one predictive variable that's categorical, and that's our gender in this case, and it's got two levels, so there'll be two groups. So I'm just going to split our data by those two groups, and then we're going to create two XY scatter plots and two correlation coefficients, one for each of those groups. I want to take the movie duration and the age in years and split it by gender. Well, look, I've already got it organized by gender. Remember what we did here. We just copied the females and the males separately. So let's plan to do that again. I'm just going to insert some cells to give us some more room. I held down the Shift key with my other hand to select that whole block. I'm going to copy that. I'm going to edit my title so that I don't forget which is which. I'm scrolling down to the first male record, and I'm going to scroll down to the bottom of the male records and take my other hand I'm just going to update those. So I already had it sorted by gender, so I didn't need to do that. And then I've cut out the movie duration and the age for the actresses and for the actors separately. I'm going to highlight those and copy them and jump back to see it and paste. There I've got age by duration and gender. Let's see, I want to get rid of that one. That was the whole group. And now we've got, does movie duration predict the age for the actresses? And does movie duration predict the age for the actors? And under my wrench, I can say show the line and show the R value and apply to all. We've got very different patterns here. For the men, for the actors, wow, that R value is absolutely 0. The age, the duration has no correlation to the age of the award. We're just as likely to find short movies with young men as we are to find long movies with young men. We're just as likely to find short movies with old men as short movies with older men. For the females, however, we've got a totally different pattern. As movie duration increases, the age of the winning star decreases. Short movies tend to have older actresses. The longer, if the winning movie was longer, it tended to have a younger actress. Let's copy those out and add them to our write-up. They're a little bit ugly. We might be better off to recreate them in Excel. I'm just going to make some notes on my write-up. I'll come back and edit them and make them more smooth at the end. Let's paste those 2 screenshots in. I'm going to shrink them down so they're a reasonable size. It might be very clever to also include the overall group. That might help you tell the story. We didn't export that one. Let's come back and export that. Let's start making some notes. We're going to start with the 2-variable comparison, and then we're going to drill down into the 3-variable comparison. When considering the entire group of best actors and best actresses, we see no relationship between the length of the movie and the age of the winning star. So that's a statement that just sums up that finding. And in order to make that statement, I need to tell what R was calculated. And that's a point, or negative 0.06. We need to include a sentence that interprets that. Maybe something along the lines of short movies were just as likely to have young stars as long movies were. However, when we divided the group by gender, a different pattern emerged. So that's a nice transition sentence that's setting our readers up to know what's coming next. For the actors, there was still no relationship between movie duration and age. R equals 0.0. However, for the actresses, there was a negative correlation. R equals negative 0.2. Is that what it was? Yes. R equals negative 0.2. And now we need to interpret that. We need to add a sentence that interprets that. I'm going to write those two sentences. So we're going to say the longer movies tended to have younger or older? Younger. All right. And that is the sentence that interprets that finding.